My student friends, my name is Shivraman. I am the founder of Edumate Plus, an online test series portal for JEE, NEET and MHT CET. I have started this YouTube channel Edumate Plus, which is the name of our online test series, with the aim of discussing questions from our platform, which may be analytical, factual or conceptual. This attempt of mine, I hope, will help you declutter chemistry. We are continuing with, after the first video, the second video on the chapter of D and F block elements, our chemistry tidbits, where we are trying to look at some questions which would evade your sight and notice while you are studying. Okay, so our YouTube channel can be used as a final source of revision when at the end of the two academic sessions, 11th and 12th, where you have last 1 month, every day you can revise the concept, which can be factual, analytical or conceptual. So we have, the next question is Lorax. So when you come to manganese, see the lower oxidation state Mn plus 2 compounds are ionic, whereas Mn plus 7, plus 6 plus 7, plus 6, Mn plus 7 are covalent compounds. So what was the question which was asked? MnO was asked. So which is an ionic compound? So you come across MnO in the reaction of KMnO4. Is this point clear? But they have picked the question from there. Reaction of KMnO4 forms MnO, and the question is MnO is what? Ionic. Is this point clear? Second concept that we are trying to talk is neodymium. See, what happens is generally lanthanides, characteristic oxidation state is plus 3. Some of them show plus 2, some of them show plus 4. Those which show plus 2 like to go to form the more stable oxidation state, plus 3. So plus 2 to plus 3 is oxidation. These are good reducing agents. Elements like cerium, which has plus 4 and would like to become stable, plus 3, undergoes reduction. So it's a good oxidizing agent. Is it clear? So one question which they can ask is what? Which lanthanoid element is used in volumetric analysis? So at your level in 12th standard, you are using KMnO4 as an oxidizing agent for 3 reactions: ferrous ammonium sulfate, oxalic acid and hydrogen peroxide. But at higher level of studies, we do not use KMnO4. Why we do not use KMnO4? Because KMnO4 undergoes atmospheric oxidation and forms MnO2, concentration can change. So there we use a solution of ceric ammonium sulfate. So cerium plus 4 becomes cerium plus 3, acting as an oxidizing agent. So then what about neodymium? Neodymium is the only lanthanide. So that's the fourth question. So indirectly in this small speech of mine, I have discussed 3 questions which can be converted into MCQ. And this is the last concept. Neodymium is the only lanthanide. Neodymium is the only lanthanide which shows plus 2, plus 3 and plus 4. So this is an independent multiple choice question. Which lanthanide can show plus 2, plus 3, plus 4? So it is neodymium. Now see, we are trying to answer a multiple choice question. Which element has D2, a D2 configuration configuration in actinoids. So you can see over here the first element actinium. I once again repeat, as I done in my earlier video, that actinium is a D block element. It is not a F block element. Why? It has a 5F0 configuration. The next element, thorium, okay, this was 89, so 90, atomic number 90, will have a configuration 5, it should have had 5F1, 6D1, 7S2, but that's the only element which has 5F0, 6D2 and 7S2. Very odd. So if you look at the configuration of all the actinoids, this is clear. That is from thorium to lawrencium 103. Thorium has 6D2. So very generally we tend to neglect looking at electronic configuration. It looks confusing, boring, all said and done. I agree with you. But then let us try to squeeze out the important point in electronic configuration. This is a differential behavior. So you should know that. Is this clear? See, we have studied that in this chapter, D and F block elements, that potassium dichromate is an oxidizing agent, KMnO4 in acidic medium is an oxidizing agent, KMnO4 in alkaline medium is an oxidizing agent, KMnO4 in neutral medium is also an oxidizing agent. So which is the strongest oxidizing agent among them? So the decreasing order of oxidizing property, decreasing order of oxidizing power is surprisingly KMnO4 in the acidic medium has a stronger oxidizing agent as compared to K2Cr2O7 in the acidic medium as compared to KMnO4 in the alkaline medium. Is this point clear? Because this has a higher standard reduction potential. Is this clear? So they can turn this question and ask which of them will have the higher standard reduction potential. So this question then becomes a part of electrochemistry also into it. Is this clear? So because it's a strong oxidizing agent, it will have a higher reduction potential. So this is how they can twist and turn the concept into one or many MCQs. The fifth question of the second video of tidbits in chemistry. We are now coming to a question, like see, normally when you talk about an oxidizing agent, so any oxidizing agent, generally any oxidizing agent, okay, always oxidizes potassium iodide, that is iodide to iodine. So you take chlorine, bromine, add into potassium iodide, you get iodine. KMnO4 acidic, iodine. Potassium dichromate acidic, potassium iodide becomes iodine. The exception to the rule is that when you react Ki with KMnO4 in alkaline medium, normally this point is missed by many students, because I know trying to by heart write many times and remember all these equations, I mean at the end of the 2 years of studies of 11th and 12th it gets cluttered. So declutter here this is very important. It's an odd behavior. So this can become a scope for a multiple choice question. KMnO4 plus H2O plus, so in the acidic alkaline medium what happens? We get MnO2 obviously, plus what do we get? We get KOH, and more important is we get KiO3 or IO3 minus. So the only case which is this is potassium iodate. So this is an exception, that iodine gets oxidized to iodate. In all other cases if you see, iodide gets oxidized to iodine. So this question has been asked very many times in entrance exams. Is this clear? If you like the video, please subscribe our channel and press the bell button. We will be going on giving you in the future updates about other chapters also. If you like the video, please subscribe our channel and press the bell button. We will be going on giving you in the future updates about other chapters also. Please post your comments. Your valuable suggestions will be appreciated, and this will go a long way in helping you only, our student friends. Is this clear?